meeting is being recorded.
Hello, and thank you everyone for joining the April 13th edition of the SIG Network Sync. Just a reminder that this meeting is under the Kubernetes Code of Conduct, which boils down to please be nice to one another. We have a fairly full agenda for today, so we will be kind of trying to keep an eye on time and keep each section down to a reasonable amount of time so we can get through hopefully everything. And with that, I think we'll just go ahead and get started since we've got a lot to do. Hopefully everybody can see my stuff.
Yes, sir.
Let's go ahead and get started on triage. So we have 3 here that are not assigned to anybody. First one is a failing test. Pod should cap back off at max container back off. Slow node performance.
Well, is that SIG Network?
I don't know. SIG network help. Okay.
Okay, tag me there.
What'd you say?
Tag me there and send it to me. I can check
Sure.
it. Right?
Thank you. Appreciate that. All right, so Antonio will take a look at that one. Let's just move on then. Endpoint slices objects become stuck in a state where IP condition differs, not ready versus ready. So we recently upgraded Kubernetes from 120.12 to 124.10. Go ahead.
I have a bit of context. This was reported in the Slack, and this is an interesting use case. They upgrade 3 versions in a row. So one from 120 go to 124. And there is also some external controller that Sandor is not here, that modifies the endpoint or the point slices. I don't remember. So, and Sandor that used to come to these meetings, not here, has an internal team in Zalando that is checking on that. But
Gotcha.
They
So
upgraded. They did a big skip upgrade.
that was impressive. So the use case have hundreds of thousands of clusters with 2 or 3 nodes, and they do that very often based on the conversation. They do
But in this case, they had an external influence changing their endpoint slices that caused the problem.
That's the working theory, and it seems that is going through that.
Gotcha.
Also, 1.24 is kind of old with respect to endpoint slice controller bug fixes.
Yeah, and I was checking between 120 and 24, we have all the endpoint EA, point SICA, right? So I wouldn't be surprised something that had the store in previous version didn't upgrade well or something. I don't know.
Yeah, at this point, isn't 124 out of our supported version range?
Nope, 124 is still supported.
We just released 127. I thought we did.
But this
124 is supported for a couple more months.
Okay.
We have to give people time to upgrade, which is actually an awesome segue to my topic, but we'll get there.
Yeah. Okay. I think I've looked at this just briefly this morning. I'm happy to help triage this, but it is troubling that they're unable to reproduce the issue. I don't know how much we can do if we can't reproduce it.
Well, it sounds like it's a desert of question marks right now. So I think we appreciate you just kind of going in there and seeing if you can move it forward at all and get some more information out of them.
Yeah.
Right now it's waiting on this other Patroni operator. I mean, the conversation was continuing in the Slack chat.
Gotcha.
Is this in SIG Network channel or somewhere else?
Yes,
Right
I can tag you.
Okay.
Something is weird. Just so you know, Rob.
Yeah.
So all right. Thank you, Rob. And then I don't know if this is what you were just asking a second ago, but they did link that other thing where they're having more conversation about this in their other repo right here. So. Cool. All right, then the last one that doesn't have anybody triaging it, kubeproxy and IPVS mode, TCP connection lost when node recover to ready. Let's see who touched this one last. Okay, this one's still kind of fresh. So the client connects to a workload, contains pod A and B by cluster IP. When the node which pod A belongs to becomes not ready because of some reasons, unstable stuff, but the network is healthy. The node is recovered.
You can assign this to me, Dan.
Okay, thank you. All right. Cool. Thank you for taking a look into that one. And that gets everything covered, I think, with somebody to triage it and move it forward. All right. Let's not waste any time then. Let's get right into the KEPS review. Jordan, you have the first topic here, which you seem eager to share.
I am. I'm so excited. Can I share my screen? Is that possible?
Yeah, give me a sec.
Diagrams.
There you go.
All right, cool.
And then there you go.
Thank you. This works. All right, can everybody see that? Awesome. All right. So I am spinning up conversations about expanding the skew that we support between control planes and nodes very slightly. Right now, we document that we support nodes being 2 versions older than the control plane. And when this was originally created, or this policy was originally created, that covered the oldest supported version and the newest supported version. So the oldest node would work with the newest control plane because we released, we supported 3 minor versions at a time. When we switched to an annual support cadence and annual support policy, we realized as part of that, we realized that users actually need time to qualify and upgrade. Like people don't upgrade 1 second after we release a new minor version. They actually try it out and then it takes, a month or 2 for them to roll it out. So we actually now support 4 minor versions for a period of time following a new minor release. So we just released 127. So now we support 127, 126, 125, and for a couple months, 124. And so what this means is that the N-2 skew that we currently have no longer covers oldest node to newest control plane during that window. And one of the big motivations for the annual support cadence was so that people could do an annual upgrade if they didn't really care about new features. If they were happy with the functionality they had, keep their nodes and control planes on a given minor version, pick up security fixes, and then wait a year and then upgrade their control planes step by step, and then upgrade their nodes. I have a diagram that shows what that would look like. So they imagine a future, they're on 140 and they run 140 for a year, they're super happy. And then we release 141, 142, 143, and now they want to get everything onto the newest version. Today, because we only support node control plane skew of 2 versions, they actually have to hop their nodes twice. So they upgrade their control planes a couple versions, but then to stay in skew, they have to upgrade all their nodes. And that's actually a super disruptive step. Like upgrading nodes means draining workloads and restarting workloads, and everything in the cluster restarts or gets rescheduled, recreated. Then they upgrade their control plane in that last version, and then they have to do all their nodes again to get onto the newest version. And so the goal of this proposal is to get us to a point where someone who is happy with what we're currently giving them feature-wise and just wants to stay on like versions to get security fixes and stay supported, their upgrade could look more like this. Run for a year, do their control plane upgrades, and then upgrade all their nodes once. So that's the goal, that's the motivation. I'm here at SIG Network because SIG Network owns kubeproxy, which is a node component. And so the questions I have for SIG Network are, what types of things would this change impact? And originally, I was looking at what we document, like for supported SKU, and what we actually document is that kubeproxy must be the same minor version as kubelet on the node. And so I thought, oh, well, that's awesome. That's simplifying. Like, then the only thing that really matters is the APIs that kubeproxy is using, and we kind of got those to V1 when endpoint slice went to V1, and like I think we're pretty good now. But then I started digging and noticed that we mentioned things in KEPs about like SKU between kubeproxy and kubelet, talking about like IP tables, ownership, and things like that. And so, as is often the case, this proposal raises other questions like, is this accurate, or are we actually expecting kubeproxy to be versioned with the control plane and SKU to the kubelet? So I have more questions now than when I started, but that's the context and the questions. Like, what would it cost SIG Network to be able to handle one newer version of control plane, and what would it cost SIG Network to handle one more version of SKU between kubeproxy and kubelet?
So I already commented some on the agenda when I saw it this morning. I think the reason why we used to claim that kubelet and kubeproxy had to be the same version was because there were just these weird interactions between them with creating the same IP tables rules and expecting the other one to create exactly the same rule with exactly the same value. And after KEP 3178, that no longer happens. So I think kubeproxy no longer cares about kubelet at all. As long as you have a kubelet newer than 1.25 or newer. No, sorry, as long as you have a kubeproxy 1.25 or newer, it doesn't care what version of kubelet you use. So, and then, for control plane stuff, like, yeah, if we add new APIs, we may have to deal with SKU stuff again, but that's just the same as every other component.
Okay.
And the reality is, we know some people do run kubeproxy as a daemon set. So linking it to the kubelet version doesn't really make sense. So we should probably just fix that doc.
I mean, I think accommodating both methods of deployment makes sense. Like immutable nodes where you put the stuff on the node and you have kubelet and kubeproxy and they just sit there that version until the node goes away. That makes sense. Daemon set, I think, also can make sense. We
Yes.
probably want to update the doc that currently says you have to freeze it to kubelet.
Dan, do you want to take that doc update? Go find wherever that doc lives and
Sure.
Okay. In terms of APIs, like there are a bunch of hands. I just want to mention one thing about the APIs. When we got all the required APIs to GA, I think in the 119-ish timeframe, we actually paid a lot of attention to avoiding taking new hard dependencies on not yet stable APIs. So there's jobs that run, a GA only cluster and make sure that all the components can function properly without beta APIs turned on. And so I think if we had a new beta API rollout, it would be a conditional type of thing where if it's available, we use it. If it's not available, we actually just use the stable APIs. So I'm pretty confident that we wouldn't take a hard dependency on a new unstable API. All right. I don't know. I can't see hand order. So.
Cal had first.
I just wanted to say that we also have to have a rule that no more dependency between kubeproxy and kubelet, because the situation now that we had dependency, we broke the dependency. So just to ensure that everybody looks at KEPs, anything that comes between proxy and kubelet is no go, and that right now we don't have that documented anywhere. So we need to have that. So I completely agree with what have been said so far. I just wanted to add that point. The point that also came to mind is the beta API and alpha API. Will we ever run a situation where proxy depends on some alpha APIs that does not exist in kubeproxy in a situation like this? And by does not exist, I don't mean it's Rift. I mean completely does not exist. imagine a situation where, let's say endpoint slices during early days was shipped in kubeproxy and kubeproxy got updated, but the control plane did not. Is that a situation that could happen?
We already have a rule that says kubeproxy cannot be newer than a control plane, and we're not suggesting to remove that rule. So I think in that case, it would be a misconfiguration. We do, Antonio just said in the chat, talking about beta APIs, you know, gates govern everything right now. So if you were to turn on a gate in kubeproxy and not turn that gate on in API server or something, then again, it's sort of a misconfiguration. I think we don't have any examples, I think, where we taste test to see if an API is supported, and if not, go around it. Although we could, we just haven't really had any need for it.
Yeah. So that brings me to the questions that we always ask ourselves during API design. There is no hard rule currently anywhere that says you should upgrade your control plane before your nodes. Can we start to have this rule somewhere written clearly?
There is though.
There is a hard rule. Yeah. So I mean, that's what we document, and we say the API server must always be at least as new as the nodes.
Okay, so I think we're fine. Thank you.
I actually had a thing, but it was mostly just asking a little bit about tests, but we're running low on time, and then I did find the section in the KEP where we're talking about E2E tests. So I'll follow up there. Go ahead, Rob.
Yeah, my main question was on the same thing. So yeah, I think we're thinking alike there. Glad that there's a test plan for N-3 nodes. You know, I think I'll just have to follow up on the KEP, but I've just been trying to think of little things we could get tripped up with API changes. You know, I think the most recent thing would be the terminating condition on endpoint slices. I think we did everything correctly there, that it wouldn't have been an issue. But yeah, I'll follow up on the KEP. I just want to make sure that we're not missing anything around, and I'm sure, Jordan, you would know, but I just want to make sure that there's no small little detail in how we've done previous changes that would get us into trouble here.
Yeah, I did sweep back a couple of years. I mean, we do a lot of feature rollouts, and usually we don't wait for the oldest node to support a feature before we enable a new feature. And usually it's like an opt-in kind of thing. Like if you want the new feature, you got to upgrade your nodes, and old nodes just won't be aware of this and you won't get the behavior. Like that's how we typically design things, and they fail safe. The cases I could find where they didn't fail safe, we did wait until the oldest node we supported understood the feature. But there were actually very few of those that I found. I also linked to a KEP that Daniel Smith is working on that is proposing like improving how we roll out features instead of just wait a release and then enable and then wait another release and then wait another release, like a more active, intelligent, hopefully, way of managing feature rollout. I see that as complementary to this. This is really saying like issues we already have with like N-2 nodes don't know about features, we would also have with N-3 nodes. But if you know of cases where we were waiting for the oldest node to support a thing, and this would actually delay feature enablement, that would be helpful to know. The ones I found were mostly around like policy, security, authorization type things where it was dangerous to relax too soon, but that would be helpful to know.
Tim, I think you're next.
Tim.
Oh, sorry. You know, one of the things we have talked about doing but never really instituted, because it seems like a butt ton of work, is setting up our own EDE regimen, like Node EDE, that just exercises kubeproxy against different API server versions, like actually run the tests against N-1, N-2, N-3, or +2, +3. Maybe we should come back to revisiting that idea.
Yeah. The other last question, I know we're past time here. Is there, you know, I know there has been some pressure to avoid perma beta APIs. You know, we need to get these APIs moving. Is there a chance that that could conflict with this if there's an API that is somehow dependent on, all nodes understanding?
We have a 3 version deprecation period. So no, it works perfectly. Basically, if we take like when we endpoint slice went to V1, like it went to V1, if kubeproxy updated to use V1 in the version where it was available, then and remember, API servers have to be at least as new as the nodes. Then the 3 versions in deprecated before the beta version goes away, like covers this. So kubeproxy updates to V1, and 3 releases later, V1 beta 1 goes away, and we're actually good.
One tiny nit there for endpoint slices, we had to do some extra delay because we had to wait till like when you upgrade, you have to wait for endpoint slice controller to write using the new API version. I think it all mostly lines up, but there had to be, you couldn't just, I'll follow up on the cap. I may be missing some details.
If you have an edge case there, yeah, definitely leave a comment. Think about it.
Okay. So yeah, let's add that to the AI as well. Okay, so good conversation. We are kind of, we hit about 15 minutes with this, so we should probably move it more into the cap, but we have several action items that look like things that we can follow up with in the cap, which is linked at the top of the doc. That is issue number 3935 in enhancements. Thank you, Jordan. All right, I'm going to go ahead and get back to sharing the screen here. All right. AKHIL ping 4 review.
Hey, yeah, I just wanted to draw some attention to this cap. I know we discussed this in a previous SIG network meeting, but essentially to move the endpoint slice reconciler parts of the controller into a staging library. So yeah, it just would appreciate some more reviews. I think Rob already took a look at it and approved it, but yeah, that's it.
Cool. I see.
Who's officially listed as approver?
I think Tim.
It should probably be. It should probably be Rob. Rob, are you cool with that?
Yeah, I already. So I can't actually approve it, but I have already added an LGTM on it.
Okay. Next time I scan through caps, which should be probably next week, I'll give it a quick pass. But if Rob's already approved it, like in my opinion, that's approved.
Cool. Thanks.
I think we lost Shane. I don't know if anyone.
Yeah, I think Shane
else.
froze. Yeah.
So, Andrew, you take the floor.
Yeah. Sounds good. Let me, hopefully I have permissions to share my screen. Let's see here. I think I do. Can y'all see that all right? Let me see if I put it in slideshow.
Yep.
Can you still see it?
Yeah.
Okay, cool. Yeah, so I'm gonna time box myself. I'm gonna go really fast because like we have a lot of stuff to talk about. And so I'm gonna start my timer now. No longer than 15 minutes. So yeah, I just wanted to come here today and present a project I've been working on for a little bit called BPFD. And basically I'm gonna give a quick overview of what it is, how it applies to Kubernetes, and like kind of how it applies to this SIG. So if you could hold questions till the end, that'd probably be the best. Awesome. So BPF, like many folks here know what BPF as a technology is. I'm not going to dive deeply into it. There's a bunch of resources out there. A lot of folks here have expressed interest or expressed like wanting to use it in their applications. Basically, at a high level, it's just a powerful framework built into the kernel now that allows you to run sandbox programs there in the kernel with kernel native speed, and albeit with a lot of restrictions. Okay, and it has like a wide array of uses. So those include networking, monitoring, tracing, security, among others. So this presentation is actually one I'm planning on giving to SIG Node and SIG Security at some point too. And we're seeing kind of the demand for BPF increasing steadily. Obviously, everyone in this group knows about Cilium and Calico, two CNIs using BPF as a technology. They have been for a long time. And I'd say they're really active in their downstream development of BPF on Kubernetes. We also have projects like Pixie, which is related to observability, CubeArmor, which is related to runtime security, Blixt, which is already been approved by this SIG to become a SIG project. We're just kind of going through some licensing constraints, and that's going to be a project for Gateway API L4 conformance. And then I also threw in one from Red Hat, NetObserve, which is another open source observability operator that relies on eBPF. And I say eBPF, really I mean BPF. We've kind of call it BPF. We chopped off the E, but we might have to go back to actually doing eBPF. So what are some of the challenges for BPF and Kubernetes? These are kind of large standing. Essentially, BPF requires like extreme privileges, right? For a pod to load BPF programs and kind of interact with BPF maps, they have to be privileged, and specifically they need cat BPF permissions. As an even more astute example, the NetObserve operator requires all these permissions. So cat BPF, perfmon, netadmin, sysresource, just to kind of get their stack up and running. There also is no program cooperation. So if you run Cilium on your cluster and they deploy an XTP program, and then you have a customer who wants to deploy an app with an XTP program, well, you're out of luck. Something's going to break, either your customer's app or Cilium. And the behavior is very undeterminate at this point. So that interference is really undefined in the kernel at this point in time. Debugging and preventing problems when you deploy BPF and Kubernetes is really hard. There's no great tools to do it, help you do it in Kubernetes, and you're kind of like picking through a node by node basis. And then also today, each BPF enabled Kubernetes application is kind of duplicating a lot of functionality. They're single-handedly compiling their BPF program into their application, loading and managing different maps, and kind of doing all that on a per application basis. When I say application, I also mean like infrastructure component, again, like Cilium. So these are some of the challenges for BPF, especially in Kubernetes. So that brings us into what is BPFD. It's basically a project we've been working on in Red Hat's emerging technology group. It's a system daemon for managing BPF programs and their life cycle. Specifically, we manage loading and unloading of BPF programs across a Kubernetes cluster, and it allows us to separate our privilege capability concerns, i.e. our daemon is privileged, but you as a user of BPFD does not have to be. We also leverage the libxdp protocol to allow multiple XDP and TC programs to cooperate on a single interface. So this is really important for our network specific BPF functionalities that you all talk about here a lot. And lastly, we're starting to focus a lot on policy and security. So you as a cluster admin, like today, an application could get a privileged pod and break the whole cluster. I mean, BPF is a hot knife. Like you can break everything like very easily if you don't know what you're doing. And so BPFD is going to help cluster admins distribute policy around who can and who cannot load certain types of programs. And it'll also provide some visibility about what programs are loaded on a cluster as a whole. Okay, and there's nothing there that does that today. Some smaller details, BPFD at its core is developed in Rust. We benefit a lot from the memory safety guarantees of that language. And then it's built on top of a Rust BPF library called Aya, which is, again, just using raw system calls in order to interact with the BPF subsystem in the kernel. It includes a Kubernetes operator, and all that is written in Go and built with the operator SDK. So most folks here are going to be really familiar with it. And then users of BPFD can still use whatever they've been using, Cilium, libxdp, Aya, etc., to get their apps off the ground and to deploy it on Kubernetes. They just are kind of using it in a little bit different flow. And we provide some client-side libraries to make that a lot easier. So I know I'm going really fast. This is kind of just a pictorial, I like pictures, a pictorial overview of what BPF deployment in Kubernetes looks like today. So as I explained before, you have each application or infrastructure component kind of maintaining their whole stack. They're calling BPF libraries in order to manage their program, manage their pinpoints, manage their maps, and they're doing all that kind of on their own stack individual basis. And all of these agents require cat BPF and other really, dangerous privileges, right? It's not really segmented. I think that's all I wanted on this slide. So what we kind of foresee as the future is something more like this, right? Today it's BPFD because that's the implementation we've made, but via APIs that we've designed, the BPF program config CRD and the BPF program CRD, you could plug and play implementations at your leisure one day. But in this deployment model, now your applications don't need cat BPF. And they can run unprivileged and deploy their BPF programs with the blessings of the cluster admin. And it also opens up the door for users, not just infrastructure components, to deploy applications safely without breaking the entire control plane of the cluster. And then, as you can see on the right, you can still use whatever map management library you were already using before. We're just kind of sitting in the load and management path. We're not really sitting in how applications interact with BPF maps. Okay, time checking myself here. I'm at 7 minutes, 30 seconds. Nice. Okay, so running BPFD on Kubernetes, these are some design details. I'm gonna go really quickly over them. I had already mentioned before, we have a BPFD operator. If you wanna test it out, go check out our repo. There's links in this slide deck. You can spin up a local kind cluster by CDing into the BPFD operator directory and running make run on kind. It all comes up, well, it should come up if everything's working. We've added some new APIs. Like I mentioned before, the BPF program config CRD is used to express BPF intent across the entire cluster. So it's what you as a user will create. And the BPF program CRD is actually kind of an internal API that we use to store per node state. And then lastly, we configure our BPFD deployment with just a SAML config map. One day that might turn into another API object. One other thing I really wanted to note on that makes BPFD special is that we've written a bytecode image specification for packaging BPF programs in OCI container images. Now, this is really important for Kubernetes because like I mentioned before, applications traditionally have their bytecode compiled directly into their application. So you can't have fine-grained version control over your user space applications against your bytecode. They're all kind of packaged together. What we've done is allowed you to reference a BPF program with just a normal container image. So everyone here is really native, really used to it. And so BPFD essentially acts as a container runtime explicitly for these types of container images to make sure we can extract the program and run them correctly on the node, on each node. It also opens the door for us to sign these in the future, kind of use that existing image infrastructure. Cool, so let me just share, this is gonna be a really quick demo, 9 minutes, share my screen. Amazing. Cool, so what I have here is just let me make that bigger for you. Oh, I lost that terminal. Is a Kubernetes cluster with BPFD up and running. What we're going to do is deploy 2 BPF programs with our BPF program config objects. The first one over here on the left is just a counter. So it'll count all the packets going by an interface. And the one on the right is actually just a pass program. But we've specified what happens after this pass program executes, and that is that it drops packets. So what we're going to do first is deploy these 2 programs, and the counter program, oops, sorry. the counter program is going to not be catching any packets because the pass program is going to be prioritized in front of it. So we've actually written a kubectl plugin to show what's going on here. So as you can see, we have 2 programs deployed. The lower the priority, the higher it essentially is. So the pass all nodes is going to be hit first, followed by your go XTP counter example. I've also deployed a user space application to read from the counter app. Sorry.
Wrong namespace, I think.
Oh, you're right. When you're typing in front of everyone, everything goes to hell. So as you can see right now, it actually might have had the demo gods against me because packets are being counted. So essentially what you're supposed to see is packets not being received, so 0 packets. Oh, actually it's 0.
Oh, no, it's frozen. It's showing you, it counted some and because the pass got loaded after. So it's doing what it's supposed to do.
Sweet. So now I can go, you'll see that the counter logs are not incrementing. Now I can edit my pass all nodes to make sure the priority is above the counter. So I'm going to bump it to, let's do 5. Go back to my logs and see now packets are starting to be caught. So this is just a really quick demo to kind of show some of the value add of BPFD. So let me just go back to my slides, wrap up here. Desktop 2, share. Can y'all see that? There's more details on the slides here about the application you just saw and how to run it. And then, so for everyone here, like what does the future look like for BPF, Kubernetes, and BPFD? Some of the broader questions we had this SIG is kind of like, we really want to pioneer like what BPF and Kubernetes looks like as a technology in an upstream sense, but we don't know where to do that. Obviously, the technology is starting to become prolific in the ecosystem. We want to ask y'all, like, where do we think this should live? Should it be a new SIG? Should it be a subgroup under one of these SIGs? And as I said, we're going to present to some other SIGs because this kind of reaches across different boundaries. How does SIG Network want to play a role in it? And then can we see one day Kubernetes APIs being endorsed by a or multiple SIGs so that we could plug and play different implementations? So instead of BPFD, someone could plug their own thing. And then the last thing is just a short roadmap. We're on the way to 0.2 release. We are moving BPFD out of Red Hat ET into its own independent org. And then we're looking to stabilize and refactor some of our core APIs. So sorry, that was as quick as I possibly could be. It was a lot of information. Maybe take like 2 minutes for questions. And yeah, I really appreciate it.
Cool. Yeah, a couple quick questions. Go ahead, Cal.
I can't help but thinking your demo this to the wrong cloud, the wrong crowd. I mean, the crowd that would be mostly interested in this are the folks who are building BPF programs, and ask them to have some sort of a compliance to a certain unified framework where users can just install some sort of a watchdog or Uber controller that control all of this, right? I can't help also but thinking, if we, like, there are 2 things to this, how it works, right? And the API. The API comment you made around like, hey, having a singular API might make sense so people can start building common tools and then plug in implementation. That I agree on, but I can't help but thinking like, what if I want something else? Like, what if I just want to install? So, because the way I look at, like, the way the customers, at least the ones I talk with, they usually have 1 or 2 tools. Nobody is in the business of randomly loading things, as far as I know, right? So yeah, sure. Like a developer, yeah, I load everything. Like, yeah. Right. So,
I think I fully agree with you. I think like there's a lot of interest around BPFD or BPF as a technology in Kubernetes, and everyone's doing their own thing. So I'm not saying we here need to do anything, but I would like to rally all those folks who are interested in a central Kubernetes-esque place so we can talk further, to be honest.
To add on that, and just so everybody's aware, I'm a contributor to this project. I kind of said that I thought this would be an okay place to bring it up because it affects people that do networking. I'm writing eBPF programs. It is obviously very big in the networking space today, but it is not meant to be a specific SIG networking thing necessarily. That's why he's going to be looking at like a couple of different SIGs and stuff like that. But I think over time, especially since we are doing things like, at least in KPNG, having an eBPF backend, like eBPF is going to be a part of SIG networking, kind of already is, but it could be more of a bigger part in the future. It's good to kind of get something on the radar. At least that's the way I look at it. But we don't have a ton of time, so go ahead, Tim.
I think Mache was ahead of me in line.
No, go ahead.
I think it's great. I love BPF, except that I don't get to play with it very much. So I don't think this is exclusively a SIG network problem because eBPF is not exclusively a network technology. Yep. I am just glancing at the APIs without digging really deeply. I'm a little worried that they're still very flexible. And there's a lot of, it seems like there's a lot of opportunities for people to blow their own feet off. It's not a foot gun, it's a foot cannon.
Oh yeah.
So proceeding here, one of the things I would ask to look for is how do we provide a potentially more opinionated, more rigorous guardrail system that lets people do interesting things without at least lowering the caliber of the gun pointing at their own feet.
Agreed.
And I don't know which SIG would really own this. I think the appetite for net new SIGs is pretty low. And so like in order to justify a new SIG, we'd have to show some critical mass, right? So I wouldn't have a problem with SIGNet sort of being the parent SIG for exploring this.
Okay.
If it's ultimately successful, then yeah, probably it demands its own SIG.
Yep.
But it's also a cross project between instrumentation and networking and probably a number of the more technical SIGs.
And that's the viewpoint we wanted from you, I think, is like, so we have to start somewhere. Like this group is the best group at making Kubernetes APIs, right? Like, and we need it. We need y'all help. Like I've built an API here, and I've built this API, and like it's just my brain. It needs to be other people's brains.
Cool. Yeah, so we can continue to, we are running really low on time with a couple things left on the agenda, but thank you for demoing and bringing that up. It doesn't seem like we have any more hands. We should follow up and continue to figure out where it can live. Go ahead.
I just want to leave another comment for context. I know BPF is big. I know it's important and I know it's prolific, but I just want to bring to your attention in terms of networking, it's not the only cool kid out there. DBDK is still thriving, right? As a matter of fact, most of the things I have seen is DBDK based. So I just want to think about this in form of, if you want to think about it in form of API, I agree we do API relatively well because we take the beating relatively well here, right? But in terms of networking, if you want to talk about networking and networking programmability, then DBTK should also be a part of the discussion.
One of the things we never did with IP tables, we never laid out an extensibility framework for people who wanted to do some other thing with IP tables, where to drop their thing in and what the semantics they could assume would be. And this was a pain point for lots of people. So let's, as eBPF becomes a bigger thing, let's not make that mistake. That's one of my biggest concerns here.
Makes sense. All right. Thanks again, but we are running low on time, so let's move on. Mache, do you want to go ahead and talk about multi-network questions?
Yeah, sorry. In our discussions came up so those two questions, and we would like to know is, do we have to design for those cases? So basically, two cases that we were thinking is, first one is creating a cluster, because this is possible when you do manually, creating a cluster that will have different CNI per node. Is that something that we have to designed for, right? When we in our multi-network, right? And then the other question is similar. What I'd like to know, what is the percentage of usage for that, so such cases, and is that something that we need to design for? So the first one would be what I mentioned, like each node having a completely different CNI, because today it's possible, right? If those CNIs, let's say, somehow integrate with each other, or maybe I don't care about like the cross-node communication works in each of them individually. Do I have to have a case where an address for that? Team.
I think the unfortunate answer is yeah, you have to accommodate that. I don't know how often it's done. Dan comments that it's done occasionally. I think that is behind the curtain, and anything that's operating in the cluster scope really ought not be aware of what's going on behind the curtain.
All right, and I see Dan's thank Dan for your as a response. This is very helpful. And then probably similarly to the next one is probably connected to the previous, and I see you're even Dan, your response probably answers my question, right? Are we supporting a manual CNI config change? And I see that yes, we do. So one thing is having
what do you
cluster
mean
with yes.
What do you mean manual CNI config change?
I have a running cluster. I went to one node, and because I assume I don't have any what I want to say, I don't have, unless I create some automation, but on my own, but then go to the node and change my CNI config, right, to completely something else. And let's say I do some other operations, maybe like draining the node and do the whole operation to now restart the node to have this new CNI stuff set. That's what I meant here.
So this is a recurring topic. We were talking about it just this morning, this distinction between the cluster provider and the cluster operator. You know, for self-managed clusters, that's probably the same person, but for like cloud providers and for managed clusters, it may not be the same people. We have never asked the question before, so we don't have an answer. Who owns the CNI config on a node, the cluster operator or the cluster provider? If you, in your statement, Maciej, if the you who is making this change is the cluster provider, it seems clearly in bounds. If it's the cluster operator, they may be running afoul of assumptions that the cluster provider is making, right? Like I know on the GKE side, if you log into a GKE node and change the CNI config, it might technically work, but if something goes wrong and you call our support people, they are not going to help you, or they're not going to be able to help you. They'll try. So, and that said, I also know that it has been an important thing for people to try things out in order to do that. But I think we as a project need to be clearer about what the guarantees are and who owns which set of APIs.
And that sort of goes along with what I was saying about very carefully in the OpenShift migration case. Like we don't support arbitrary random CNI changes and skewed CNI plugins. Like we have very specific ways that it can be done that are documented and tested and supported.
All right. So
right,
it's a very
OpenShift is the cluster provider there, right?
Right.
That makes sense. And
then you do like very well designed, well tested out approach for. So basically, your answer Dan is for basically the other part of my second question, right? Your use case from you don't create a per se cluster with different CNIs. You definitely want to change the CNI during the life cycle, but you don't create on purpose cluster with a different CNIs. Is that true?
That is true.
So basically, you don't have a case where with different CNIs, you definitely want to want to change it with a fully tested case. But okay, but still, even from that team, you're saying that even the different CNIs per node is something that we would have to address. Okay.
What do you mean? One question, Tim. Sorry, because when you mean different CNIs per node, what do you mean exactly? Different CNI plugins as having Calico and Cilium, or different
Imagine
CNI
I have
has-
a I don't know, I have black boxes. I don't know what it is, right? They all have their own. One is, let's say, Mac VLAN, the other one is V8 interface, the third one is Calico, right? And those three, let's assume they all can collaborate in my and it can communicate between each. They do satisfy the conditions of all the pods can talk to each other, right? Can I do that? Should I address for that? Like one node does in Mac VLAN, the other node is doing, I don't know, vSphere, and the last one is doing Calico.
I think we should not build things that assume that those are the same when they don't need to be. So like the simplest example, I have one node that's using a bridge and one node that's just using P2P. But those both emit IP. They're compatible at the network level, but they're different CNI implementations. Is that allowed? I think it has to be.
That's what I mean. Okay, yeah, that's the answer. Okay, thank you.
Antonio, I can't tell if you're convinced or not.
No, I was, when I have the slides for this, because when we talk CNI, and depending on the different people that we are talking, it means one thing or the other, and I was confused.
Yeah, no, I'm not saying like if your CNI does an encapsulation format that you have to be compatible with the CNI that doesn't. But I'm saying we shouldn't assume that they're the same implementation or the same version or the same anything inside the node.
All right, thank you. That's all I want to know.
Thank you, Maciej. All right. So we are 4 minutes. So I don't think we're really going to get through everything, but Antonio.
Yeah. Wait, I will do in 1 minute, and we have for that. So next week you come. I don't know who is going, but we can talk offline, and I'm going. So we can talk offline. We need to have lunch together as we always do. And the second topic is about this, because this weeks we were talking about the pod network. I created some slides to really try to describe what is the current state of the pod IP and the kubelet and how this is cascaded to Kubernetes. So take a look, maybe something wrong, add comments, and see if we can have at least something documented.
Okay.
Yeah, that's it.
Okay.
And then my item after that, so a bunch of us have been talking about like refactoring kubeproxy API into something nicer and eventually supportable by other people. And since it's all written out, this is mostly just sort of a roadmap to a bunch of PRs that I'm going to be filing. And like some of them, I know Antonio is going to be looking at them and being like, why are you doing that? So I sort of wrote out the whole plan so that so people can look at it or not, but that's it.
It's amazing what we'll let you get away with if we know where you're going with it. It's amazing what Jordan will let me get away with if he knows where I'm going with it.
Yeah, because you have 88 commits PR. 106.
Cool.
So,
right.
Dan, you are going to do small PRs then?
Yeah, I've already written a lot of it, and there are links to the branch in my repo there. But yeah, I'm gonna file it as small PRs.
Okay, and you already started.
Yep.
Okay. So more reading.
Cool. So yeah, Dan's working on a refactor of kubeproxy, and if you are interested, the doc is here in the meeting notes. Please check it out. All right, and we did actually get through everything. Just in time. So cool. Well, for those of you who will be at KubeCon, see you there. We will get together, check the SIG Network channel, and we'll probably make some noise about when we're doing a SIG Network lunch. And otherwise, we will see everyone in a couple of weeks after KubeCon.
Have a great time, everyone who's going to be there. Serious fear of missing out. Don't post back how much fun it is, because I don't want to know.
I'm not going to look at Twitter all next week.
It's Amsterdam. How much fun could it be?
Come on.
Just a little.
Amsterdam in late April.
Just don't eat anything that people offer you on the streets. I think it's fine.
It won't
Cheers,
be fun
everyone.
because Ricardo won't be there.
No,
I will
please.
be watching.